Good afternoon, everyone, or good morning or good evening, depending on when it is you're watching this. This is the final lesson in Unit 7. Unit 7, of course, is permutations, combinations, and the binomial theorem. Since this is the final lesson of the final unit, this is the final lesson of the entire course. In the previous lesson, I taught you about the binomial theorem. It was called the Binomial Theorem Part I, and we expanded binomials that looked like that. X plus y raised to an exponent. And that exponent had to be a whole number, like 0 or 1 or 2 or 3 or 4 or 5, etc. And we used in our work yesterday a number of tools. We used Pascal's triangle. We saw there was a connection between these expansions and Pascal's triangle. We also used a pattern. And the pattern was basically that there's a connection between the exponents on the pieces of a term, and there's also a connection between the exponents on the pieces of a term with each other, but also there's a connection between the exponents on the pieces of a term with the exponents on the pieces of the next term. There's a pattern, and I'm going to review that in a bit. But what we're going to be doing today is doing the same kind of work we did yesterday, but not relying on Pascal's triangle. And that's going to involve an understanding of how to use this formula. And I will admit it looks pretty intimidating, but it's not difficult at all. However, in order for me to tie a connection between what we did yesterday and the formula so that the formula becomes simple, let's look at an example here. X plus y raised to the 5. Now, yesterday what we said was we told you that if it's x plus y to the 5, then that means n is 5. And by the way, the n value of 5 is the same as the n value in this formula that we're learning about today. When you see n choose k and x to the n minus k, that n is the exponent on the binomial. So in this case, n is 5. What we learned, maybe learned is a hard word here to use, we didn't really learn it, we maybe reminded ourselves of it, was that when you expand a binomial by raising it to an exponent, you get one more term than the value of n. You know, the very classic example of this, and I'm not going to run through a whole bunch of them, is if you have x plus y raised to the 2, that means x plus y multiplied by x plus y. And if you expand that out, you get x squared plus xy plus xy plus y squared. And that gives us x squared plus 2xy plus y squared. Those are three different types of terms, and that means that when we have x plus y raised to the 2, we end up with 3 terms. So if we have x plus y raised to the 5, we end up with 6 terms. What was new yesterday was we saw there was a connection between those 6 terms and the numbers in the 6th row of Pascal's triangle. So yesterday we would have to look at the 6th row of Pascal's triangle. There's Pascal's triangle up to the 6th row. What does that mean? It means that we need to make use of these 6 numbers: 1, 5, 10, 10, 5, 1. And we start off by writing those numbers down. The first number is a 1, and then a 5, and then a 10, and then it becomes a 10, and a 5, and a 1. And I've spread these apart because I know that these are going to be 6 terms, and these numbers are just parts of each of those 6 terms. They're also going to be added together, but I need to include more in this. We learned that since n is 5, the first term will contain x to the 5. We saw by looking at different examples that what then happens is the exponent on x diminishes or drops or goes down by 1 each time until you reach no exponent on x. And if you've done things right, you will end up at the last term. We also said that the first term doesn't contain any y's, but as x loses an exponent each time, y picks up the slack. We still need a total of 5 for a sum of the exponents. So in the first term, it's y to the 0, then y to the 1. then y to the 2, then y to the 3, then y to the 4, and y to the 5. And this is the expansion of x plus y raised to the 5. I want you to notice something, though, that the sum of the exponents on the two terms, x and y, when they're put together as a product in the expanded form, the sum of those exponents is always n. So 5 plus 0 gives you 5. 4 plus 1 gives you 5, etc., all the way down the line. We did a few problems using this set of ideas yesterday, and then I introduced you to something, and I said, you know what's interesting is if you look at the numbers in Pascal's triangle, they're connected to combinations. That 1 is the same as 5 choose 0. This 5 in front of the blue term is the same as 5 choose 1. So the coefficient of the first term is 5 choose 0. The coefficient of the second term is 5 choose 1. The third term is 5 choose 2 for a coefficient. Then it becomes 5 choose 3, 5 choose 4, and 5 choose 5. I want everybody to notice that if you have 5 items, there are 6 different ways you can make choices. You can choose, and feel free to count on your fingers, and I'm not, joking here, I'm being serious. When you count these off, 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. That gives you a total of 6 options, and that's kind of how we explain that we get 6 terms. To finish this off, I just want you to note that x to the 5, y to the 0, or 5 choose 0, x to the 5, y to the 0, that's what we're going to call the first term, t sub 1. The blue term is what I'm calling t sub 2. We're going to call the red term the third term, the orangish term the fourth term, the fifth term is that one, and the sixth term is the final term I've got. And now, before I try to make this into a connection between yesterday and today, I want to point out some patterns here that are always true. The first thing that I would like you to note is that the number you're choosing out of 5 in this example always matches the exponent on y. So when it's 5 choose 2, you're going to have y to the 2. When it's 5 choose 4, you're always going to have y to the 4. 5 choose 5 will be y to the 5. I also want you to notice that in the choices, in the combination aspect of things, the 5 is n. So every term has the same n value. We're choosing out of n each time, but each term has a different number that you're choosing. There's a couple of other things I want you to note. I want you to note that these two exponents always add up to n. 5 plus 0 is n. 4 plus 1 is n. 3 plus 2 is n. 2 plus 3 is n. 1 plus 4 is n. 0 plus 5 is n. They always add up to n. And there is one last absolutely crucial thing you need to know. And that's that the term number is different than that yellow number. That yellow number, what I've highlighted in yellow, is different for each term, and what that number is actually called is the key number. And what is important is the key number is one less than the term number. This is absolutely fundamental before we go on. That if you take a look at, I guess I will use a green highlighter. If you take a look at the term number 1, term number 2, term number 3, term number 4, term number 5, term number 6. The term number is always a little bit bigger, specifically 1 bigger than the key number. The key number, which is yellow, is 1 less than the term number. If you are ever asked to find the 7th term, then you have to use a key number of 6. All right, now let's put this together. Let's get back to our notes. There's the formula, and I've talked about it already. It's on the formula sheet. So we call that the general term of a binomial expansion, and it can be used to determine any term in the expansion of x plus y to the n without completing the entire expansion and without going to Pascal's triangle. Each term in the expansion has a unique value of k. The value of k is always 1 less than the term number. So k is determined by which term you're finding, whereas n is determined by the binomial you're expanding. More on that in a second. Let's take a look at the first example. What is the 5th term of this expansion? Well, let's write down what we know before I start talking about the 5th term. We know that x is not actually x here, it's 2x. And y is not actually y, it happens to be negative 3y. And hopefully you remember that you should put negatives in brackets. And n is equal to 7. Listen, this is crucial as well. These 3 things are for all the terms. If you ever wanted to find the 1st term or the 2nd term or the 3rd or the 4th or the 8th term, and there are going to be 8 terms here because n is 7. If you ever want to find any of those terms, all of those terms will use the same x, the same y, and the same n. However, what's different is the k value. Since we're trying to find the 5th term, k is equal to 4. So this parameter, or value, whatever you want to call it, is for T5 only. Only term 5 uses k equals 4. So when you take a look at the formula, I'm going to put the formula up here. Don't worry about the k plus 1. I'm going to have to explain that in a bit, but it's the least important thing. The formula says n choose k, x to the n minus k, y to the k. Well, we're going to use that to find the 5th term. I'm not going to write k plus 1. I'm just going to write t sub 5. Well, it's n is 7, choose 4. Then I have to put x, and this is how I do it. I don't put the exponent on my x yet. I put the exponent on my y because I know that my key number in every term when I do this, my key number goes in these 2 places, always. So as soon as I see 7 choose 4, well, then I know that y is raised to the 4. Then what I do is I simply say that this other exponent on x has to add to give 7. The sum of the exponents is always going to give you n. Well, that means this is 3. And what I've done is I've used my patterns in setting this up, but to be honest, I haven't really used this formula piece by piece. I haven't actually said n minus k. I could have written 7 minus 4 up there, but I just said it must be 3. So I want to point something out to you now. When we talk about this 5th term, the 7 choose 4, the 2 raised to the 3, and the negative 3 raised to the 4, this is going to form the coefficient. We also have up here an x cubed and a y to the 4. So when you take a look at that 2x, that 2x is in brackets raised to the 3. That means 2 has to be raised to the 3 and x has to be raised to the 3. The 2 raised to the 3 is going to be a number, so I've moved it out in front as part of a coefficient. Similarly, negative 3 times y, quantity to the 4, means negative 3 to the 4 and y to the 4. So what I've done there is I've just moved the negative 3 to the 4 out in front. So what we're going to get here for an answer for t sub 5 is some numerical coefficient times x cubed times y to the 4. And I'm going to end it there because, quite frankly, I don't think we need to spend time staring at a computer screen and time with me making a video for something that you should be able to figure out. Figure out what 7 choose 4 times 2 to the 3 times in brackets negative 3 to the 4 is later on, or you can pause the video and do it. That's going to be the coefficient of the fifth term. Let's try example 2 now. What is the sixth term? Well, this is really weird because, well, not really weird, but it's different because our, quote, x in the binomial is 3x, and our y in the binomial is negative 1 over x squared. And what that means is that there's the true variable x in each piece of the binomial. So all of our terms are not going to contain x's and y's or a's and b's. They're just going to contain numbers and x's. N is equal to 9 here. And again, this is for all terms. This is raised to the 9, which means we're going to get 10 terms. Every single one of those 10 terms could be built using that x, that y, and that n. However, for the sixth term, we must use k equals 5. And all we do is load things into the formula. The sixth term will be n choose the key number, which is 5. So it's going to be 9 choose 5. Then we're going to have our x, which is 3x, raised to an exponent. We're going to have our y, which is negative 1 over x squared, raised to the key number. And the exponent on x has to add to the key number to get n. It's got to be 4. This means that your sixth term will have a 9 choose 5 contributing to the coefficient. It will have a 3 raised to the 4 contributing to the coefficient. It will have a negative 1 raised to the 5 contributing to the coefficient. It's also going to have an x raised to the 4, and it's also going to have a 1 over x squared raised to the 5. That x squared in our y is actually on the denominator, or in the denominator, so it's over that. Again, what you're going to get here, I'm not particularly interested in. Your sixth term will have a coefficient. You can feel free to figure out what 9 choose 5 times 3 to the 4 times negative 1 to the 5 is. And then this other part will end up being 1 over x to the 6 because what you have is x raised to the 4, and it's multiplied by 1 over x squared raised to the 5. When you have 1 over x squared to the 5, that means you have to take 1 to the 5 over x squared to the 5. We're ending up with x to the 4 over x to the 10, which is 1 over x to the 6. So this is our answer right here. Again, it's not a true answer because you still have to figure out, if you care, what 9 choose 5 times 3 to the 4 times negative 1 to the 5 is. Example 3. In this expansion, one of the terms involves b cubed. What this means is when you expand this out, there might be terms that have b to the 12. There might be terms that have b to the 0. But we're interested in the term that has b cubed. And what we need to know is which term. I want to be very clear here. That's not what the question is asking. But in order for us to find the coefficient of the term, you have to know which term it is. You have to know whether it's the first term or the second term or the third term, because we need to know what k is equal to. Look, we know that x is b squared. We know that y is negative 3 over b. We know that n is equal to 9. That's true for every term. But for this term, we need to know the value of k. So how do we determine the value of k? What we do is we basically make a table and we go on an exploration and we ask ourselves, if I find the first term, what will the first term contain for b's? I'm not even going to worry, everybody. I want to just go back here for a second and look at this formula. I am not going to worry about the n choose k right now. All I'm going to worry about is this part of the formula, because that's the part of the formula that's going to determine the variables. And I am after b to the 3. So T1 contains what? Well, T1 will contain x, which is b squared, raised to the n, and it will contain y, which is negative 3 over b raised to the 0. This is going to contain, for b's, b to the 18. If I simplify b squared to the 9, I get b to the 18, and the other part is 1, so I get b to the 18s. That's what I get for b's. What will the second term contain? Well, the second term will contain a b squared raised to the 8, and it will contain a negative 3 over b raised to the 1. So, look, quite frankly, I don't care about the negative 3. I care about the b's right now. And this will be b to the 16, which is b squared to the 8, over b to the 1. This will contain b to the 15. And some of you might realize why the exponent on b is dropped by 3, and that's great. If you're not sure and you want to see if you can figure it out, you can pause the video and see if you can puzzle it out. But I simply want to tell you that if you've established that the exponent on the variable drops by 3 each time, then that pattern will continue. The next term will contain b to the 12, the next will contain b to the 9, the next will contain b to the 6, the next will contain b cubed. And that is what we are after. We are after the term in this question that contains b cubed. So what does this mean? Well, the third term contains b to the 12, the fourth term contains b to the 9, the fifth term contains b to the 6. It's the sixth term that will contain b cubed. And everything we did to the right of this line was done just so we could determine that k is equal to 5. It's the sixth term. Well, now we know k is 1 less than the term number. It's 5. And the rest of this question is really easy because it's just like example 1 and 2 now. The sixth term will equal to n, 9, choose 5, multiplied by x, which will be b squared, raised to an exponent. That exponent is going to be 4, but let me talk you through it, times y, which is negative 3 over b, raised to the key number, and the exponent on x has to be the number that when added to the key number gives you n, which is 9. So this is that term. If we simplify it, the sixth term is 9, choose 5. It's also going to contain a negative 3 raised to the 5. It's going to contain a b to the 8. You might just want to roll that around in your head and see how I got b to the 8. It's b squared raised to the 4. And this will also contain an over b to the 5. This should make you a little bit happy because we're supposed to get b cubed, which means the coefficient, which is the answer to this question, it's what you were asked to determine, will be whatever 9 choose 5 times negative 3 raised to the 5 is. And again, feel free to work that out. That's the answer. Number 4. Number 4 is basically the same idea as number 3, except it doesn't tell you the exponent on the variable that we are after. It does tell you that there is a constant term that we're trying to find. Constant term means you are going to have no variables. So what do we know? X is actually x squared. Y is actually negative 1 over x. N is the exponent on the binomial, which is 6. We need to know the k value for the term that's the constant term. We need to know for this, what is k equal to? So how do we do it? Well, you find out how many x's are in the first term. The first term will contain the x squared raised to the 6 and the negative 1 over x raised to the 0. It's going to contain x to the 12. The second term is going to contain the x squared raised to 1 less exponent. I'm not even using the formula here. I'm just using the pattern we established yesterday. And it's going to contain negative 1 over x raised to the 1. Well, x squared to the 5 is x to the 10, and we're dividing by x to the 1, which is x to the 9. This, just like the previous example, has a decrease of 3 for the exponent, which is going to continue. I feel that I should point out it's not always going to be this way. Don't make an assumption that this always happens. But what that tells us now is we can continue with this table until we get x to the 0, because that is the term we're after. So the third term will be x to the 6. The fourth term will be x cubed. It's the fifth term that will give us an x to the 0. And that means k is 4. And we're just about done now, because we've turned this into, and I'm always fond of saying this, you turn problems into problems you already know how to do. You know how to find this term now. You're simply going to, I guess, use the formula. And I'm going to write the formula down this time so I can get out of the way an explanation of what that k plus 1 is equal to. What does that mean? tk plus 1 is n choose k, x to the n minus k, y to the k. Well, this is going to give us 6 choose 4. We're going to have x, which was actually x squared in this example, raised to an exponent. We're going to have y, which is negative 1 over x, raised to the key number. X needs to be raised to a 2 because 2 plus 4 is 6. So why on earth does this say tk plus 1 if we're finding the fifth term? Well, k is equal to 4. K is equal to 4. Four plus 1 gives you 5. That's why it's written as tk plus 1. But as I said earlier, I think I did, don't worry about the k plus 1. You don't even need to write it. What you need to be able to do is put the stuff into the right-hand side. All right, to finish this off, we're going to have 6 choose 4. We're also going to have negative 1 raised to the 4. We're going to have x squared squared, which is x to the 4. This will be over the x to the 4 that's in here. Well, again, that pleases us mathematically because that's what's supposed to happen in this question. We are after the term that's constant. By the way, negative 1 raised to the 4 is positive 1. All of this is simply 1, which means the fifth term is whatever 6 choose 4 is. All right, we have one last example to go. This last example is more challenging. I think we've gone through these in about a half hour, so if I play my cards right, this video will only be about 40 to 45 minutes long. The likelihood of you seeing a question like this on my unit exam is quite high. The likelihood of it being on a diploma exam is lower. I don't want to say it's low, but maybe of the last 8, 10 diploma exams I've seen this question 4 or 5 times. So it's about 50% of the time it's on a diploma exam. If you want to know what percent of the time it's on my exam, it's 100% of the time, this type of question. The first thing to notice is, and I pulled this from a diploma exam question that I've seen. The numbers are different, but the basic idea is the same. The thing that makes this weird is there's a K in the question. And K is reserved for a key number. And K also can mean a vertical translation parameter. My advice to you, we've done this in trig with other similar kinds of situations, is to rewrite this with a different letter for the parameter. Don't use kx minus 6. Even the best student is going to get confused by leaving the k in there from time to time. So what this question is find the value of a, not find the value of k. Let's write down what we know. We know that x is actually ax and y is actually negative 6. I'm sorry, I didn't even read the question for you. When you expand this out, one of the terms is going to give us negative 224,000, so that's negative 224,000 x cubed. And the question is, what is the value of a in this original binomial so you would get that as a term? Well, n is equal to 8. We can continue with our list here. N is equal to 8. And what we really need to know is, again, which term. That's not what the question is asking. The question is asking what's a. But in order for you to determine a, you need to know whether this term is the first term or the second term or the third term or the fourth term, because that leads us to the value of k. So we're going to do an exploration. Looking at what I've highlighted in blue, I hope it's clear that the first term is going to contain, I'll write this out. The first term is going to contain x to the 8. The second term is going to contain x to the 7. And I didn't do a stellar job in a couple of earlier examples. I want to point out again that these arrows do not mean that that's what the term is equal to. For example, T2 also contains an 8 choose 1. T3 is also going to contain an 8 choose 2, but I don't care about that. By the way, at this point in time, you've established that x is dropping by 1 each time in terms of the number of x's that we're multiplying by, in terms of the exponent. So I don't think we need to continue with this middle part of writing ax to the n minus k, y to the k. We can just say the fourth term will contain x to the 5. What are we after? We're after something that contains x to the 3 if you look at the term that's highlighted. So the fifth term will contain x to the 4. So that means that the term that's going to contain x cubed is going to be the sixth term. And now we're ready to roll, because if you know that it's the sixth term, then you know the k value is equal to 5. And I'm just going to do a bit of erasing here so I have a little bit more room to finish this problem off. If you need to look at what I've erased, then you can always pause the video and go backwards. I'm just going to erase this on the side, our exploration of determining the k value. And normally at this stage of the game, you would load in your x, y, n, and k to find the term, but we don't know a. However, we do know that the term has to give us negative 224,000 x cubed. And we know that that term has to be n, choose k, times x raised to an exponent, times y, which is negative 6, raised to the key number, and the exponent on x, which is actually ax, must be 3, because 3 plus 5 will give you 8. And when you take a look at this equation, if I take the right-hand side and move the parts that are coefficients out, like I've been doing throughout this whole video, those three pieces will be forming the coefficients. The rest will be the x cubed. And at this point in time, you can cancel the x cubed. And that means you can solve for a. This time we are going to have to grab our calculators and figure out what this number on the right-hand side is. We have negative 224,000 equals, I need to figure out what 8 choose 5 multiplied by negative 6 to the 5 is. All right, 8 choose 5. I don't really care what 8 choose 5 is. I'm just going to go ahead and multiply by negative 6 raised to, whoops, in brackets, raised to the 5. And I get negative 435,456. Negative 435,456. And that means that I have to take 224,000 divided by that number. Negative 224,000 divided by that number gives me this awkward fraction of 125 over 243. So a cubed. A cubed is equal to that number. Unfortunately, even though, well, let me write this out. A will be the cube root of that. Unfortunately, even though 125 is a perfect cube of 5, 243 is not a perfect cube, I don't believe. So our answer is this, 5 over the cube root of 243. And that is the value of A in this final question. So I believe this video, I haven't really been watching the clock, but it feels as though it'd be about 40 minutes long. Again, we kind of didn't rush through, but there are some things we didn't do, like actually calculate values of coefficients, but you can do that on your own. On page 38 of your unit handout, questions 4 through 13 are continuing with the types of problems that you were working on in the last lesson, except now you have the benefit of understanding how that formula works. and not relying on Pascal's triangle. There are also a few more difficult questions like the final couple of examples. I hope that helped, and we'll talk to you all soon. Take care.